All right, let's start going over some of the answers for this review. The first one was tell whether the following relationship represents y as a function of x. Well, I look at my x values, -1, 1, 3, -4, 2, -3. None of those x values repeat, so I'm going to say yes, it is a function. As long as your x's don't repeat, it is a function. Your y's are allowed to repeat. On 2, you're just going to plug in to the equation. It's just function notation. So on number 1, plug in -1, and you get 2 times -1 squared minus 3 times -1 plus 4, which is 2, plus 3 plus 4 should give you 9. On number 2, you take out the x and you put in 2x. Remember, you need to square that first, so that's going to be 4x squared times 4, which gives you 8x squared. So 8x squared minus 6x plus 4. Number 3, you need to state the domain. Well, we've got a fraction, so you just set the denominator equal to 0. Solve, and I got 0 and 1/2. So my domain is going to be all real numbers except for 0 and 1/2. State the domain and range here. Sorry if those numbers did not come out that clearly. I think when they gets uploaded, it gets a little bit blurry. My domain are my x values, which it looks like my x's are really traveling from -4 to infinity. And then my range are my y values, and it looks like my y is traveling from 0 to infinity. All right, next page. Name the zeros and the y-intercepts. To find the zeros, you just set it equal to 0. And I factored x minus 5, x minus 1. My zeros are 5 and 1. To find the y-intercepts, you plug 0 in. 0 squared minus 6 times 0 plus 5, and you get 5. You could also put that as an ordered pair. Sketch a linear function that has a negative slope and is discontinuous at -1. There's a lot of different answers on this one. And I will tell you there's going to be one like this on the test where you're going to actually have to sketch it. So you could have put that anywhere on there. I could have put at x equals -1 and had a negative slope here. Well, and it doesn't even need to be the same slope. It could have been still negative like that. So there's going to be a wide variety. You just need to have something that's discontinuous at x equals 1. So on 8, they're asking which value of x is it discontinuous? Well, it's discontinuous when it doesn't exist in the denominator. So take that denominator, set it equal to 0, and it's going to be 2. So you're going to have a discontinuity at x equals 2. All right, on 9, there is going to be some problems like this. So the graph of, I got fancy and I put the function notation and y. I'm not sure why I did that. X cubed minus 9x squared plus 1. And they give you an interval. This is not an ordered pair. It's saying between x equals 0 and 3. Which two integers is the 0 located? Well, make a t-table. Go from 0 to 3. And then look for your sign change. My sign change happens right here. Goes from positive to negative. So I know I have to have a 0 between 0 and 1 because it's crossing the x-axis between those 2 points. Here's the picture. Relative maximum is a high point at 1, 4, negative 1, 4, sorry. Minimum, right there, low point at 1, 0. The zeros, that's where it crosses the x-axis, are negative 2. And at 1, the y-intercept is at 0, 2. And the end behavior is down, up. Average rate of change. The average rate of change is like finding a slope. And again, they're giving you an interval. They're saying from x equals negative 1 to 2. Find the values of your y. So plug them in. And I plug negative 1 in, I get 0 out. Plug 2 in, I get 9 out. Those are my ordered pairs. Find the slope between those two ordered pairs. And I got 3, the difference of your y's over the difference of your x's. I know we didn't spend a whole lot of time sketching. There's going to be 1 or 2 of these on the graph, and you do have Desmos available to you. And there won't be any where it gets fatter or wider like there is in A, but I went ahead and left it in here. So if you have a fraction, it does make it wider. Again, this one I really wouldn't worry so much about. On this one, you just need to know that it really shifts it down 1 unit. And again, we didn't really spend time focused on graphing. You've got graphing applications available to you. Utilize them. And again, same type of thing. Whoops, that changed colors. I did not know that it would change colors. Write an equation. This, I went ahead and left in there. It's a reflection. We did not talk about reflections, but that's where that negative sign comes from. And a translation 2 units down is just going to be your -2. Within the absolute value, it needs to be paired with the x. And 1 unit down is the -1. And you can always check that on Desmos. All right. This one looks like it should be hard, and it's not. So which of the following is not included in the piecewise function? Now, piecewise function just contains pieces of a function. So I look right here. We've got a horizontal line, and that is x. I'm sorry, did I just put x? I meant put y equals, and that is -1. So right here, I can eliminate that. That is part of it. The next piece of my function is right here. That is a parabola. Which one doesn't have a parabola, or which one has a parabola? This is it, x squared. All right, I have one last piece. Well, it's a line, and I've got 2 lines here, but I can pretty much tell you which one it's going to be. This is a negative slope. There's only one here that has a negative slope. I rewrote that. And if I were to continue this line, yeah, my y-intercept is 2. So which one is not included? It would be x minus 1. And if I wanted to, I could graph x minus 1, y-intercept of -1, slope of 1. That is not included whatsoever on here. Okay? So don't overthink this one. All right. Enjoy.